Welcome to another video from Roland Mösel, founder of Planetary Engineering Group Earth. The IPCC report from 2021. And I will show what outpoints this report has. Let's start with the size of the report. It's 3,949 pages. Imagine this, you would print it out. 25 centimeters high when printed both sides and about 50 centimeters high when you print only one side. Oh, a very huge report. It's a big diagnosis, but without therapy suggestions. First, on page 6, the basis for the net zero emission fairy tale. We have observed since decades that nature absorbs 56% of what human emissions are. Oh, we have since decades, so long time we have watched this, and we assume that this will be forever from now on. But what does this really mean? Oh, we emit 36 billion tons of CO2 and nature absorbs 56%. Okay, that's 20 billion tons. But what happens when we reduce emissions to 20 billion tons? 56% of 20 billion tons are only 11.2 billion tons. So how should this net zero emission fairy tale work when it's not a constant what nature absorbs, but only a percentage? And what is when this percentage changes? Maybe even to the negative. Maybe, minus 50%, means 100%. Next one, page 27. Not yet fully included in the climate model. Yes, permafrost and wildfires are not fully included because it's not so good understand how it works. Yes, additional ecosystem responses to warming not yet fully included in climate models. Reminds on the spell on an old philosopher, I know that I don't know. Yes, but still we have the zero net emissions guideline, despite that we don't know about it. Page 86. Yes, permafrost. We think that per 1 degree Celsius more temperature, it will decrease 25% the part 0 to 3 meter below Earth. And we have it not included now. Page 103 to 104. We estimate between 3 and 41 PDC per degree Celsius. What is PDC? Never heard before from this shortcut, but for luck I can look it up in the report, and it is petagram carbon per grad. A very usual shortcut, PDC, petagram carbon per grad. Now we convert it to CO2 per grad, and surprise, it's at 41 PDC is 150 billion tons of CO2 per degree Celsius. When the warming is 5 degrees, it's 750 billion tons of CO2. It's 20 years of human emissions, and this could happen in years, but they have a range of 3 to 41. A very big range. Imagine you are Christoph Columbus and you search an investor for a ship to find a new way to India. And the investor asks you, how far have you to go to west to find India? I estimate between 300 sea miles and 4,100 sea miles. I think the investor would not react positive on this answer. He would say, oh, try to find it better out before you ask me. We don't even know further crucial components of this task yet. We are now on page 107, and we have here two statements. We don't know. There are great uncertainties, and only a few sentences down, we don't give up the belief that net zero emission is the big solution. We have to believe it. And on page 221, there's a low agreement that there is already CO2 emissions and methane emissions from permafrost. It sounds like what has not to happen cannot happen. We don't believe it. It has not to be. Yes. What conclusion out of this report? There's always that we have a CO2 budget. Oh, we have only 5 years at current emission level left. I don't believe it after reading this report. I think it's very properly that our remaining CO2 budget is already far below zero. So don't forget this budget with the CO2 emissions. It's very likely that it's already used up. The only target we should have is the planet renovation. And planet renovation means as fast as possible to reduce to real zero CO2 emissions and then to filter out CO2 out of the atmosphere and split it again in carbon and oxygen. That's the only real target. And I made already a video about it, and this video is calculated that we have until 2032 increase of solar panel production of 26% per year. Why 26? Oh, because this is in 3 years doubling. In 6 years, 4 times the production. This is 26 per year and doubling every 3 years. And because the demand for climate actions seems to be so low by this report, net zero emission, that other studies are influenced by this. I found IEA report, International Energy Agency, who shows this about photovoltaic energy production. Yes, in 2025 and 2030 should be an increase, but next page I see here is assumed an annual growth of only 15%, not 26, 15%. And this change in the speed of increase of photovoltaic production has dramatic consequences. I made already this video, and this is with the 26% yearly production increase until 2032, and in the year 2055, 18 terawatt yearly photovoltaic production. Here is a maximum reached at 437 ppm, and 400 ppm is reached 2054. I call this first scenario the naive scenario because nature continues all the time to absorb 20 gigaton CO2 per year. There's not much different when the photovoltaic production increases only 15%. It's only 1 year different. But at the next scenario, the differences are much increasing. In this scenario, nature changes from absorbing 20 billion tons CO2 per year to emitting 20 billion CO2 per year, and the change is by 1 billion ton per year. Here is the maximum in 2051 at 476 ppm, and 400 ppm are reached again in the year 2080. At the slower increase of photovoltaic production, this changes to 514 ppm in the year 2064, and 400 ppm are reached only 2099. Now a more drastic scenario. Nature changes from absorbing 20 gigatons CO2 per year to emitting 30 gigatons CO2 per year, and the change is by 2 gigatons a year. Here we have at the fast photovoltaic increase of production a maximum of 542 ppm in the year 2058, and 400 ppm are reached again 2117. With a slower increase of photovoltaic production, the maximum is at 596 ppm and only in 2068, and 400 ppm are reached again in 2141. And the last one is a real catastrophic scenario. Nature emits here more than humanity just right now. It goes up to 40 gigatons greenhouse gas emissions of CO2 equivalent per year. At the fast increase of photovoltaic production, maximum is 2062 with 559 ppm, but we reached only in 2183 400 ppm again, and now the slow production increase. Here we go up to 624 ppm in 2072, and 400 ppm is only in the far, far future 2214. So it's very important to understand that that photovoltaic production and battery production to store solar energy for the night time has to increase at the maximum possible rate as fast as possible. And politics has to make all the things that all this production is used up to motivate the industry to increase as fast as possible. One important part of this will be the new construction standard of the Climate Protection Superiority House. I made already a video about the general requirements of this new construction standard. It's far beyond anything of construction standards currently in use. And let's look what this could mean to humanity. CPSHE is Climate Protection Superiority House as shortcut. And in average, the photovoltaic will be 50 kilowatt. At the first prototype we will make next year, it's a very small house with only 30 kilowatt, but the average will be much higher, 50 kilowatt. And 2 billion of this are 100 terawatt of photovoltaic. And the recommendation is to have 3 kilowatt hours of batteries for each kilowatt of photovoltaic. So an average house has 150 kilowatt hours of batteries, and all the 2 billion have 300 terawatt hours of batteries. The yearly electric yield will be, at a single house, 65 megawatt hours. The average will be much more south than Austria and Germany. In Austria and Germany, it's much smaller, maybe 45 megawatt hours per year, but the average will be more in the south, where the solar yield is higher. and for all the houses 130 petawatt hours. This is 4 times the total electricity production of mankind just right now, but this is necessary. Food production, in average, 80 square meter of vertical gardening aeroponic systems integrated in a house, and this makes 160,000 square kilometers of vertical gardening aeroponic systems for all. Living space, maybe 100 square meter per house, it's 200,000 square kilometers for all. And now everybody will say, oh, so much houses, only one floor, how much space will this require? Oh, one house, maybe with the street for to come to the house, about 800 square meter in average. And these are only 1.6 million square kilometers for all the 2 billion houses. This is very small compared to the huge effect of this new building standard. 130 petawatt hours of electricity are far beyond the energy needs of mankind today. Always remember there is a big difference between electricity and thermal energy. Usually at many applications you can replace 3 kilowatt hours of thermal energy by 1 kilowatt hour of electricity. And it's called Climate Protection Superiority House because the target is far beyond the energy transition. When only the energy transition would be the target, it would be called the Energy Transition Superiority House. No, this is only a stage goal in between. The real goal is the planet renovation. And for this, we have to use huge amounts of electricity to filter all the CO2 out of the atmosphere and split it in C and O until we have reached again only 350 ppm, which is considered a safe level. Real climate protection is only possible when the living standard of the people will rise, and we will have to measure the living standard at the poorest 10% of humanity. Here we have to show how the living standard improves. And this will be possible because of all the synergy effects of this system. Energy production, food production, high living comfort, and the security in areas which require the option F for fire or W for water. Imagine a wildfire comes, all the village is evacuated, no chance for the fire department to do something against it, and the house fights until the last droplet of water and will properly survive, and you can again go in the house and live in it, has survived a big wildfire. And the other option is water. Oh, the water is 4 meters high, but the house swims on it, and after some days the water disappears and the house is exactly at the same place as before the high water has come. These are special options for dangerous areas where you have to expect wildfires or high water. This was another video of Roland Mösel, founder of Planetary Engineering Group Earth, and as always, like, comment, subscribe, and hit the bell to be notified when I make my next video.